Hey guys, here's part 2. So we're going to go ahead and start solving these. This is a show your work, so show as much as you can. So 25 says solve algebraically for x. Okay, I see my inequality. Kind of acts as an equal sign when you start solving for a variable. So I'm going to draw a line down to separate my two parts. And usually for these inequalities, they want you to move the x's to the right. And by that I mean, if you look at the 1.02x and the 1.04x, which one is bigger? 1.04 is bigger than 1.02, so that's why I want to move it to the right. So you want the small moving to the right. So what's the opposite of a plus? 1.02x. It's a minus 1.02x. So what you do to one side, you gotta do to the other side. And these will cancel. I'm left with 3,600 on this side. I have a 2,000 here. And I am going to keep my positive 0.02x on that side. So now I want my constants to the left. So I'm going to subtract 2,000 on both sides. So now I'm left with 1,600 over here. These cancel. I have 0.02x on this side yet. Divide by a 0.02. And when I do that, 1,600 divided by a 0.02, I'm left with 80,000. My sign is not an equal sign, it's a less than sign. Got to remember that. And this is an x, because these cancel. So that will give you 2 points. Moving on. 26. Okay, it says the number of people who attended a school's last 6 basketball games increased as the team neared the state sectional games. The table below shows the data. State the type of function that best fits the given data. Justify your choice of a function type. Okay, so if I look at this, I'm going from, here's my games, 13, 14, 15, 16. So the games are going by 1. So if I look at how much is increasing, I'm always adding 87 on each one. So this is increasing at a constant rate, 87. And since I'm adding the 87, I know it's going to be linear. So it's going to be a linear function. And y, it increases at a constant rate of adding 87. Okay? That'll get you 2 points. If you just say linear function, that's 1 point. 27 says solve x squared minus 8x minus 9 equals 0 algebraically. Explain the first step you used to solve the given equations. Well, guess what, guys? We can do this algebraically with using the calculator. And the way you do that is you go to your y equals, type in x squared minus 8x minus 9, second graph, and I want to find my zeros in the y. So my 1, 0 is going to be, looks like, at -1, and the other one is going to be at +9. So that means I know my x is going to be -1 and it's going to be +9. So now I'm going to work kind of backwards because my factors are going to be the opposite of those. So it's going to be without the equal sign, so it's going to be x plus 1, and this is going to be an x minus 9. And since it said equal to 0, I set that equal to 0. So that is, and then I could just rewrite this above the original that they gave me. So what they want you to do first is actually get the factors and then get the answers here, or the solutions. But that's a trick using the calculator. It gives you the solutions. You just have to remember the opposites to get the factors. So explain the first step you use to solve the given equation. You could say, I found the factors of your minus 9 that combine to a, as always the b, negative 8. And you can say that. That'll give you your 2 points. Okay, moving on. Number 28 says state all time interval. Let's read the question first. 28. The graph of F&T models the height in feet that a bee is flying above the ground with respect to the time it traveled in t seconds. So the height is the y-axis here, and the time is the x-axis. It says state all time intervals when the bee's rate of change is 0 feet per second. Explain your reasoning. 0 feet per second would be all horizontal lines, so lines that go completely straight from left to right. So I'm looking right here from 2 to 6, and I'm looking here from 14 to 15. So the way I could write that is from 2 less than or equal to x less than or equal to 6, and from 14 to 15. So it'll be 14 less than or equal to x less than or equal to 15. And it says explain your reasoning. Horizontal lines indicate a rate of change of 0. Okay, moving on. 29. Graph the function 2 of x minus 7 on the set of axes below. So first thing I'm going to do, I'm labeling my graph. 0. So all the positives go to the right and up, which means then all the negatives, when I write them, are going to go from the left, negative 1, negative 2, negative 3, and then going to be down, negative 1, negative 2, negative 3, negative 4, negative 5, so on. Okay, so I know there's a second part. I know there is a second part of the question, but I'm going to solve the first part first. I'm going to write on the left f of x equals 2 to the x minus 7, and I'm going to get an xy chart. And let's do that right now. So I'm going to go to y equals, clear that out, 2, then the to the button, remember, is the arrow right here above the divide sign, to the x minus 7, press second graph. I'm going to get my table, and I don't want anything below negative 10, but I also want whole numbers here. So I'm going to start at 0. Why not? Let's start at 0. So 0, 6, or I'm sorry, 0, negative 6, 1, negative 5, 2, negative 3, 3, 1, 4, 9. I'm going to stop there because the next one's going to be way above it. So I'm going to go ahead and graph that. 0, negative 6 is down here. 1, negative 5. 2, negative 3. 0.3149. So this is an exponential function. I should know that anyways because I'm raising the power is a variable. I'm going to graph it as carefully with showing the curve as I can with the arrow because it's going to go on forever, and it goes on forever as well this way. Now it says if g of x is 1.5x minus 3, determine if f of x is greater than g of x when x equals 4. Justify your answer. Well, why not graph this one too the same way? So g of x equals 1.5x minus 3 xy. And just so that the reader of the graph knows that this is f of x, we could label that f of x. So y equals, clear that out, 1.5x minus 3, second graph. So again, I just want whole numbers, so I'm going to have 0, negative 3, 1, negative 1.5, 2, 0, and 3, 1.5. Let's go to 4 because they're asking about it when it's 4. So 4, 3. So right off the bat, if I look at my two XY charts, when the input is 4, the output is 3. When the input 4, it's 9. So the answer is going to end up going to be yes. Does it tell us to graph it? It doesn't, but let's just graph it anyway so I can show you what's going on. So here's 0, negative 3, a 1, negative 1.5, 2, 0, 3, 1.5, and then 4, 3. You're going to use a ruler. I'm just going to try to freehand it the best as I can. Straight line, arrows on the both. So when x is 4, my g of x is 3 here, but my f of x is 9. So is 9 greater than 3? Yes. And you could put that. You could say f of x is greater, and using that, 9 greater than 3 should more than justify your answer. Okay, moving on. Determine algebraically the zeros of 3x to the third, 21x squared, plus 36x. Before I plug this part into my calculator, okay, I should notice that they both have an x, so I can take out an x. And 3 is divisible by 21 and 36 evenly. So I could take out a 3x, which then in my parentheses, I can get an x squared plus 7x. And over here would just be a plus 12. So it says determine the zeros. We're going to set it equal to 0. So we can plug in this portion because we have 3x equals 0 so far when we split it. And then this should equal 0. So how do I solve for x here? Divide by 3. X equals 0 for this part. So now I'm going to have this part to deal with. So go to my calculator. I have x squared plus 7x plus 12. Second graph. Finding the y's where it's 0. So it's 0 at negative 3 and at negative 4. So I know this is going to be negative 3 and a I think I typed it in wrong. Let me take a look here. X squared plus 7x. No, I'm right. Okay, so x equals a negative 4. So now, again, to find the factors, which should be the middle step here, you want to write the opposite. So the opposite of a -3 is a +3. Opposite of -4 is a +4. X, don't forget to set equal to 0. So these are the zeros of that function. Okay, moving on. 31 says Santana is considering a vacation and has obtained high temperature data from the last 2 weeks from Miami and Los Angeles. Which location has the least variability in temperatures? Explain how you arrived at your answer. All right, this is the one I'm going to use, the TI-84. So the way you plug this in, notice this is one variable because, you know, there's no, like, this is not your X and this is not your Y or vice versa. This is just a set of data. All right, set of days when these are the temperatures here for Miami and these are the temperatures here for Los Angeles. So this to me sounds like a statistics problem, okay, where you're trying to find like the range, your interquartile range, and your standard deviations. So I'm going to go ahead and first type Miami in. So the way you do that, I'm going to show the calculator up here. I know you're not going to be able to see the screen when I enter in the data. But the way you do that is you press Stat. You go to Edit. If anything's in L1 or L2, you want to clear it out. So you go to Up, Clear, then back down. And it clears the whole row. So over here, go to L1, press Clear, press back down, clears it all out. I'm going to do one at a time. Okay? I'm going to do Miami first for my L1s. So I'm going to type in 76, arrow down to get to the next one, 75, 83, 73, 60, 66, 76, 81, 83, 85, 83 again, 87, 80, 80. Okay, just a quick check. Looks like I got 14 of them, and there's 14 there. They're all double digits, but I notice I put a 50 in there, and I want that to be an 80. So we're going to make that an 80. So we got to make sure you type them in correctly. Just a quick check. It doesn't take more than a minute to check them. Okay, so now you're going to go to your calculator. Since you typed all your data in under Stats Edit, you're going to go to Stat, go to Calculate, and it's a one variable statistics, so that's number 1. Go down to Calculate, and it gives us a whole bunch of junk, and we're going to tell you what it all means. All right. So we got the X with the line over it is your mean. That's your average. Okay. You have your summation of X. So if you add them all up, you get 1,088. If you square it, adding them all up, you get 85,284. You have your sample standard deviation. That's the SX, which is 7.49. And you have your population, which is that weird sign over there, is 7.22. And that's the one we're going to want, your population standard deviation. Okay, N is the number that you entered in your L1, so there should be 14 of them. The min is exactly what it means. It's the minimum number of that set of data, which is 60. Q1 is quarter 1, which is 75. MED is your median, which is 80. Quarter 3 is your third quartile. Your max is the highest number in that set of data, 87. All right. So what we want from that is going to be your standard deviation, your range, and your interquartile range. All right. So let's go ahead and do that. So for Miami, Okay, you're going to want your population standard deviation, your min. Why not just put them all down? Quarter 1, quarter 3, your max, your range, and an interquartile range. So these you're going to have to find, but it's pretty easy with the data that we got. So we were told that this is 7.2. We're told the minimum was 60. Your quartile 1 was 75. Your quartile 3 was 83. Your max is 87. Okay, your range is your max minus your min. So 87 minus 60 is 27. And your interquartile range is your quarter 3 minus quarter 1, which is 8. So now we're going to find for LA. So you go back to your calculator, press stat, edit, clear L1 out. So I'm going to clear it out, press down, and I'm going to go ahead and type in all the temperatures for Los Angeles. So we have 74, 63, 65, 67, 65 again, 65, the third 65, 62, 62, 72, 69, 64, 64, 61. A quick check to make sure that I have everything typed in correctly. And it seems to be correct. So now I'm going to go ahead, back to my calculator, press stat, go to calc, number 1, it's one variable statistics, my L1 list, and I'm going to calculate it. So that gives me my mean and everything again. So I'm going to write that down. My standard deviation is 3.63. Or just round to 3.6, I guess. Why not? Okay. My min is 61. My quartile range is 63. My median is 65. My third quarter is 67. My max is 74. So now my range is going to be 74 minus 63, which is, I'm sorry, my range is not 63, it's my minimum. So 74 minus 61, which is 13. My interquartile range, so I was thinking about, is 67 minus 63, which is 4. So now it says, the question, which location has the least variability in temperatures? Explain how you arrived at your answer. So the least variability is going to be the smaller of the ranges, the interquartile ranges, and the smaller of the standard deviation. So that happens for LA. That's smaller. This one's smaller, and this one's smaller. Because it's smaller, the range, the variability doesn't get too high, doesn't get too low on each day. It pretty much remains consistent in the 60s over here. Okay, you got 170, or 270s rather, but pretty much remains consistent, and that data shows that. So you can write LA or Los Angeles. Let's make sure the reader of the test knows. Los Angeles, because, and you can write the range, IQR, and population, standard deviation, are less than Miami's. Okay, so that was 31. Moving on, 32. Looks like they threw us a bone with 32. Solve for x. Okay, the way I do that is by adding 5 to both sides. So we have 4x squared, 80. divide by 4. So 80 divided by 4. Make sure I get it right. 80 divided by 4 is 20. So x squared equals 20. Now I got to find the square root. Okay, so x is going to be plus or minus square root 20. If you forget the plus or minus here, it's minus 1 point. So don't forget it, because that 1 point can mean the difference. All right. So that's 32. That's part 2 of the exam. Next video, we're going to do part 3 and part 4 together. So if you have any questions on part 2, ask me in class, and I'll see you then.